on this computer. Okay. Again, hello. My name is Matt, and I'm just going to jump right into the presentation because I have slides for the introduction there. So thanks for joining today. All right. Can someone give me a thumbs up or a yes that they can see my slides? Okay. Thank you, Samantha. All right. So today for CU Data Week, my name is Matt, and I'm going to be talking about plots in R with ggplot2. Today is the 31st of January, the last day of the month. So that's great. And let's just get right into it. Okay, so just to start, I'm going to talk about my goal for the day. And the main goal is to kind of give you an understanding of the language and the grammar and like the way the code is set up for using ggplot2. Uh, there's a lot of complexity that you can use in R. There's a lot of different graphs you can make. There's a wide variety of things you can do with ggplot. And because there's so much variety and diversity, I'm not going to cover like every single possible plot you could do today. That would be way too many hours of talking and you'd get very bored. So instead, I'm going to try to give like a rough outline of how to make individual plots and how you can modify those plots as necessary. Um, so that going forward out of this, you won't be a ggplot expert, but you hopefully will be good enough to know what to Google. And Googling is really what makes you the expert. Every time I work at ggplot, I'm probably Googling something anyway. There's just a lot of things to remember, and I can't remember it all. But hopefully by the end of this, your Googling skills are great, and you can make plots in no time. Um, so the agenda for the presentation, I'm going to talk about the background of the package for a little bit. Then we'll cover the general structure of the code, what the framework looks like, what things go where. Then I'm going to hop into R. We're going to make some plots. We're going to make some plots that are slowly but surely increasingly complex, which is always fun to see your progress growing. We'll talk a little bit about changing data structures in case you have data in one format and you need to reformat it for a different ggplot approach. And then lastly, we'll talk about saving out plots, which is always important in manuscripts and publications and posters and the like. So some quick background on the package. Um, so if we step back like a decade, maybe a little more, there's this guy named Leland Wilkinson, and he comes out with this book called The Grammar of Graphics for Statistics and Computing. You can look it up on Amazon if you're interested. And this Grammar of Graphics was this really groundbreaking book that talked about a new way to make graphics, a new way to kind of focus on data visualization. Leland went on to be very successful. He sold this big software program to SPSS. Then for a while, he worked for Tableau, which is like another monstrous data viz corporation. So uh, and the reason I bring that up is because GG and ggplot2 refers to the grammar of graphics. Um, and ggplot2 is like a statistical package that you can use in R. It's like an app on your phone. Your phone comes with a lot of apps, but you can always buy more from the Apple Store. And in the same way, R comes with some things installed, but you can download this statistical package to do more things. It's akin to a Python library if you've ever used Python. And so Hadley Wickham, the author of ggplot2, kind of read this book, The Grammar of Graphics by Leland Wilkinson, and he thought, wow, this is awesome. I need to make an implementation of this framework in R. And so that's where ggplot2 comes for. If you're wondering what happened to ggplot and ggplot1, they're like really old beta versions of this. I think you can find them online if you really want to, but it's probably not worth your time. The other thing to know about ggplot2 is Hadley Wickham has like a whole universe of R packages that kind of serve as competitors to some mainline base R code. And it's called the tidyverse. And so ggplot2 is like housed under this bigger universe of packages called the tidyverse. Um, and so it plays well with other tidyverse functions. If you're familiar with any of those, we'll go over a couple of them, but that should be straightforward. Um, the other thing is that a lot of this presentation I'm doing, I took from the book R for Data Science, which is Hadley Wickham's like introduction to data science and introduction to R. for the beginning statistician or data scientist or just someone who's interested in making graphs. So if you think my presentation is terribly boring, you can just click on that link and read a book, which is also great. And lastly, the last thing to say about Hadley Wickham is that he's a very nice person. Before I knew how important he was in statistics, I was learning ggplot a couple years ago and emailed him what is now, in retrospect, a very basic question. And Hadley was happy to email me back. And I thought, oh, cool, this guy seems helpful. Only later realizing that he was actually really important. And I just randomly emailed him and he emailed me back. It's like asking Taylor Swift for songwriting advice and she emails you back. So that was fun. Hadley's a cool guy. Um, So a quick note on structure of ggplot. In the Grammar of Graphics, that book by Leland Wilkinson, he has this photo talking about how a lot of things are layered when you make a graphic. And we're not going to go over the names of these layers and the philosophy behind them. I just want you to see this picture and to absorb it and to think about layers as we go through this presentation. You can think about layers coming down like they are in this visual. And that can relate to code, how a lot of the ggplot code is in layers, or you can think of layers coming out of your screen. So if you like build one layer and you put another layer on top of that and another layer on top of that, so on and so forth, where the visual kind of comes out to you, you're adding layers to a visual. So that's all I want to say about layers is think about them during this presentation. Um, the other thing to touch on before we jump all the way in, there's a lot of visualization principles out in the world, how to make good graphs, how to avoid making bad graphs, how to communicate information visually effectively. And it's not really the topic of the day, but I think it's good to think through and wrestle with before you publish any graphs or make them for your research. Just touching on it very briefly, it's good when you have lots of information in your graph, but it's bad if you have too much information in your graph. And really, it's all about understanding your audience's background, and knowing what they'll be able to digest and interpret in a visual fashion fairly rapidly without taking a lot of time to understand what the graph is telling you. So just make sure when you're building these graphs in ggplot that you are communicating the right amount of information to the correct audience. And you'll see as we go through some examples, some graphs that are too basic, definitely some graphs that are too complex, and some graphs that are just right. So also keep that in mind. A tiny bit more background, hang in there until we get into R. We are using this data set called MT-CARS for all the examples today. MT-CARS is a data set that is naturally housed in R. It just comes with the program. And the data is extracted from this 1974 Motor Trend US magazine and comprises fuel consumption and 10 aspects of automotive design and performance for 32 separate cars. So in the left picture here, you can see this list of 11 variables that include miles per gallon, cylinders, displacement, horsepower, rear axle ratio. I don't really know that much about cars, so I can't tell you what a big displacement is. But it's interesting nonetheless. You can also tell it's an old data set because it has carburetors, and cars don't really have carburetors anymore, so that's fun. And then over on the right-hand side here, you can see the entirety of the data set actually in R. So each row represents one of the cars in this data set, and then each column represents one of those variables. We have miles per gallon, number of cylinders, displacement, horsepower, so on and so forth. I like this data set because miles per gallon is fairly continuous. Number of cylinders is kind of categorical. They all range from they're 4, 6, or 8 cylinders for the most part. Then there's things like VS, which refer to the engine shape, whether you're in a V shape with your pistons or a straight shape. So that's just a binary yes/no variable. And it's just a nice built-in data set because everyone has access to it, and there's a lot of examples on how to use it online. And then lastly, this here is our eventual goal. You can see a plot here at the bottom right, car weight versus miles per gallon. On the X and Y axis, where we color by number of cylinders and have dot size by number of carburetors. This isn't a good plot. I think it has too much information, but I've made it our eventual goal during this presentation to make this plot because I think it just kind of demonstrates the complexity of ggplot. Um, Obviously, don't make a graph with this much information. It's just too much to digest reasonably. But it does show how flexible a lot of ggplot options are. On the left, you can see that this is a fair amount of code, but we'll eventually add up to it and we'll be on our way to making great graphs. I had these slides about general structure, but last minute I decided they were too abstract. So we're going to skip them and go right into R. All right, can someone confirm for me that they see my R markdown page? Anybody? You cannot. Okay.
We
Let
see
me
slides.
let me share something else. Share screen. Okay, how about that?
Yes.
Okay, perfect. Thank you. All right, so here we have R. If you know your way around R, that's great. If not, I'll give you a quick tour. Up here is the code that I'll be running. Down here in the console is the code that it'll show that it ran basically. And then on the right side here in the viewer, I'm going to kind of have a lot of graphs pop up. If you've never used tidy, oh, the other thing, I'm using R Markdown, which is a platform basically built so that you can write analysis, you can write summaries of analyses, and you can write text about your analyses and graphs and models and all that. And with a click of a button called knit, R will actually make a report for you, whether it's in Word or a PDF or an HTML document. And I use R Markdown for a lot of stuff. What you need to know is that this chunk here, the chunks that are between like these three hashes or dots or whatever, that's like the code. And then of course I can like add titles and stuff outside of the code, but that's not too important. So let's jump right into tidyverse. If you have not installed tidyverse before, you would use this code install.packages tidyverse, which installs the library. And then of course, once you open your R session after having installed tidyverse, you always need to load the library. So I'm going to do that real quick. We can see that it's taking a while. So I installed the tidyverse package and it has all this stuff, which is great. And now I'm going to show you an example again of the plot you just saw. So this is like the end product, the plot that we are going to try to make at the end of this little course. Again, it's too complex to be reasonable, but it does demonstrate the flexibility of R. Okay, so starting off with step one and learning some syntax about ggplot. This section is 0, a dumb plot, because it's dumb. The very first command that you can use to start any plots, just to make a background, basically, to make a background for your plot, to make a plot object, is the ggplot command, okay? So if I run just the ggplot command, then you can see that my screen changed. It's just gray. There's absolutely nothing useful here. But we did technically, in the eyes of R, make a plot, okay? So that's kind of fun. Before getting slightly complex, not complex, but more advanced than that, the other thing you can do is every time you have a ggplot command, you're also going to add your data source to it, okay? So if I'm typing on line 32, I'll type data equals empty cars. I cannot type. Okay, so data equals empty cars. I'm going to run that again. Again, I just get a very non-useful plot, but at least I'm telling R what data source I want to use, okay? So that's step one, is just calling ggplot and assigning empty cars to your data source. I'm going to revisit this a lot, so you'll know it quite well by the end. Okay, so now we're going to make a basic plot that's actually useful. And so what we're going to do, we're going to write ggplot, which is the opening command you always use. You're going to specify your data source. So you're working with the empty cars data source. And then you're going to add this plus sign. And if you think back to like slide 3 or 4 or whatever it was, If you remember those layering ideas, this is the first time that the layering idea comes into practice. What we've done, we've called a plot, we've specified what our data set is going to be, and then we're adding a layer with the plus sign, okay? And what layer are we adding next? We're going to add the layer for geom point and all this other stuff I'll talk about shortly. So if I run this code, we can see that I generate a new plot, which is great. And now we actually have a plot with information on it, not just a big gray square. And what we've made is a plot showing the MPG, or rather the weight, WT, by MPG. And we can see from this that, the heaviest car is like almost 5,500 pounds. This is in the thousands. And its miles per gallon is like 11. Okay, so we're thinking about like the big family Suburban. It's a big behemoth of a car, and every time you fill it up with gas, you cry because the miles per gallon is terrible. And we can see kind of as the trend goes down, the less and less you weigh, the more MPG you get, or rather, the more MPG you get, the less you weigh. It's half a dozen of this, six of the other, whatever the saying is. So yeah, we can see this negative trend sort of between miles per gallon and weight. More miles per gallon, less weight, higher weight, less miles per gallon. Okay, so now talking about the code. We already talked about how you call ggplot, I'm making a plot. And then you call data, this is the data I'm going to work with. Okay, then you add this layer. And the layer that we're adding is going to be geom underscore something. Okay. And what all the geoms represent in ggplot is kind of like the type of graph that you want to make. I'm sure there's a more technical word for it. Or the element of the plot that you want to add. All right. So here I'm saying I'm making a plot. I'm using this data set. I'm adding a layer, and my next layer is going to be a point plot. You might know this as like a dot plot or a scatter plot. It's all the same thing. ggplot just calls it geom point. Okay, so here we're specifically saying we're making a dot plot, we're making a point plot. And then what we do inside the parentheses for geom point is we assign some aesthetics to that geom. And aesthetics is a weird word to use. Geom is kind of a weird word to use, so hang with me here. But aesthetics basically means, okay, if you're making a graph, what sort of aesthetics do you want that graph to have? And maybe a better word than aesthetics is components. What components do you want that graph to have? Okay. And so inside this aesthetics statement, we assign some components that we want the graph to have. In this case, we want X to equal our miles per gallon, and we want Y to equal our weight, right? So again, talking through this out loud, I'm making a plot. I'm saying, okay, I want to make a plot. I'm going to call ggplot. I'm going to use the data set empty cars. Then I'm going to add a layer on top of my plot. And the layer that I'm adding is a point plot or a dot plot or a scatter plot. It's all called geom point in our language. And then I'm specifying of the point plot that I want to make. I want to specify the aesthetics. And the aesthetics, I'm going to have X be the MPG. I'm going to have Y be the weight. Okay, so again, running this one more time. The spacing is different. You can see that it makes this plot. Okay. Um, any questions just after making this very basic plot? Does any part of the grammar of this or the syntax, does anything not make sense to you? Feel free to either speak or ask a question in the chat. All right, cool. I'm either a great teacher or, oh, there is a chat. Okay, what's another example of an AES you could set? Okay, that is a great question, and I will show you in a moment. Uh, Yeah, we'll just skip right to it then. Okay, so add color by cylinder. So now we're doing the same thing. We're making a plot. We're using the data, empty cars. We are making a geom point plot, and we're going to add an aesthetic to it. Okay, so before we had the aesthetics where X equals MPG, Y equals weight, and now we're going to add some color aesthetic to it. Okay, because of course these just boring black dots aren't very fun. Let's add some color to our plot. Okay, so if I run this, I add another aesthetic, we can see that, oh, there's another check. I'll get to that in a second if I don't answer it. So we can see now, looking at the plot here, that we have weight on the y-axis, x-axis is MPG, and the color of the dot represents how many cylinders they have, which is great. You know, light blue is more cylinders, dark blue is fewer cylinders. Now, the one bad thing about this plot right now is that cylinder is not really a continuous variable, yet R is using this continuous shade of blue. Uh, and that's kind of weird. And the reason R does that is because it sees 4, 6, and 8, and R thinks, oh, numbers, this must be a continuous variable. Let's use a continuous shade of blue. So we don't want that. We're going to take this code that we had above, and we're going to modify it for this code below. And the only thing I'm changing, I'm specifying my aesthetics. And of those aesthetics, I'm going to specify, I'm going to say X equals miles per gallon, Y equals weight. And then color is as dot factor cylinder, right? So same code as before. I'm just adding this thing that says as factor, which basically tells R, hey, R, this isn't continuous, even though it's got values 4, 6, and 8. It's a factor. It's categorical. Don't use a continuous color shade. So let's run that and see what happens. Ta-da! We have different colors for different cylinder sizes. And of course, I'm not gonna lie, this plot isn't very pretty. The dots are small. There's weird labels. There's no title, you know, but we'll get to that in a moment. Here's a spot where I ask more questions, or you ask me more questions. Let me look at the questions in the chat. Okay, if you just wanted to have the dots for 2 categories, would that be the same as geopoint? Let's see, if you just wanted to have the dots for 2 categories, would that be the same as geopoint? If you only wanted, so is the question if you only wanted 4 and 6, you didn't want 8? If I'm correctly understanding the question, you would probably modify your data so that you would filter only those with 4 and 8, and then you would just make the plot on that. One concept that's important in ggplot is you get your data, how you want your data to look, and then you plot it afterwards, rather than like trying to manipulate the data in the plotting process. That is something we'll touch again in the future. Okay, so next question. Why keep using the plus sign and the parentheses? What happens? ggplot is kind of a skin. Yeah, I can talk through that a little bit. I may have skipped over that a little bit. So the way R works is, if you think of English, there's like nouns and there's verbs, right? So like the dog, no, that's not a good example. So let's say you're playing sports. I threw the ball. In R, let's say I want to do I threw the ball. In R, all the verbs are functions, right? And all the functions have parentheses with them. So through, if I wanted to write I threw the ball in R, I would say through ball, which is basically ball is some object that's being modified by this verb, which is through. And so all the verbs have like these parentheses, right? And so when I'm here, I'm like, I'm taking this data, empty cars, and I'm doing something to that data. What am I doing to that data? I'm making a graph of it, okay? And then the plus is like an uncommon thing in R, so that's a good question. But that's just kind of like the syntax that Hadley chose when he wrote this package. The plus is just saying that we're adding another layer to ggplot. So I'll summarize this in what plain English again, if I'm able. Okay, so what I'm doing, I'm taking empty cars, right? I'm writing to R. I'm like writing a letter to R. I'm like, hey, R, take this data set, empty cars, okay? And I want you to make a plot with that, okay? And R's like, okay, cool, I made a plot. And then I'm like, hey, R, in addition to making that plot, I want you to make a specific sort of plot. I want you to make a geopoint plot. And I want you to do that with MPG, weight, and cylinders with these specifications. So hopefully that kind of explains a bit of the grammar of the code more. Any other questions while we're at it? I'm going to take a moment to take a drink because I'm talking a lot. I don't talk this much when I do statistical analysis by myself. All right. So to summarize so far, ggplot. We call ggplot. We're saying, hey, I'm making a plot. I'm using this data. Okay. And instead of just a boring gray background plot, I'm going to add a layer. What sort of layer am I going to add? Okay, I'm going to add a point layer. I'm going to add a dot plot. And the dot plot, they always say geom underscore at the beginning, right? So and then ours like, well, what do you want the dot plot? Like, let me tell you the aesthetics that I'm looking for. Okay, so I'm going to have x equals mpg, y equals weight, and color is going to be some other thing, cylinder number. But weight r, I don't want this to be a continuous color on a spectrum. I want it to just be categorical, right? So I say as factor cylinder, and ta-da, we have our stuff. One thing to note, figuring out what the aesthetics are in a geom object is kind of tricky. Of course, you can always ask for help. So like geom point, and then the help page will pop up. So it kind of, actually, that's not that helpful. Yeah, the help for geom, I take that back. The help for ggplot in R isn't great, although online it's pretty good. So don't be afraid to Google stuff. Okay, so another thing that we're going to add for now, we are going to add one more aesthetic to our point plot. Again, ggplot, data, empty cars, geom point, aesthetics, y, x equals mpg, y equals weight, color equals cylinder, and we're going to add a size component for carburetor, okay? So that's a beautiful plot, or getting more beautiful. It's not quite there yet. But that looks nice, I guess. Um, And you can see things are getting more complex. We have 4 things of data in here. I don't need to go over the grammar for that right now because I think you guys have it. So what I'm going to do now, I'm going to make this plot. I'm going to add a line of best fit. And again, I want us to put on our brains the image of that layering, right? So we have the plot that we made above in step 4 right here, right? But we are adding with this plus sign another layer. And that layer is going to be the geom smooth function. You're like, okay, what the heck is a geom smooth function? Which is a good question. Again, starting with geom, that's kind of just like the name of the plot type that you want to add. It considers a line of best fit to be a plot. And so what we're saying, we want a smooth line through here, and the aesthetics for that smooth line are going to be x equals mpg and y equals weight, okay? And basically, when we run that, we get a line of best fit that models miles per gallon and weight as x and y, which is great. Just for fun, I'm going to see what happens if we change this. Maybe there's an interesting lesson here. Okay, never mind. Don't do that. Sometimes there's a lot of messing around in ggplot to see what happens. Okay, so that's that. Other things that are important to know about geom smooth, actually, I'll get into that later. I'll get into that later, I promise. Okay, so now that we've talked about this, we've talked about aesthetics within the layer that we're adding. Okay, it's important to know that you can actually move the aesthetics elsewhere in the plot. So I know previously I said that these aesthetics of miles per gallon, weight, cylinder, and carburetor kind of belong to geom point since we're specifying it inside geom point. And then, of course, miles per gallon and weight are aesthetics that belong to geom smooth. But the cool thing about R is that you can cut down how much typing you do. And you can see here that X equals MPG and Y equals weight. This is kind of like redundant, right? And if you added a whole bunch of geoms and you added X equals MPG and Y equals weight to every single one, that would be kind of obnoxious and repetitive and unnecessary. So what you can do, you can actually move your aesthetics to the top line into the ggplot function. And what this does is it makes it so all of these aesthetics apply to all the subsequent layers, which is cool. You only have to write it once, and you're on your way. Okay. So we're going to run this. It's going to give me a warning and we'll kind of pick up what I messed up here and see how to go from there. Okay. So I run this, I get this warning, blah, blah, blah. I'm not going to read it right now. And I get this wonky plot that includes a sad face, actually, which is kind of fun and fitting. Um, so looking at the plot, it looks like it's made now 3 lines of best fit. Okay. Uh, the key here, the as factor cylinder, the colors still make sense, but carb is like 3 different sizes of lines, which doesn't make sense. And there's like 3 lines, but the 3 lines look like they're the same size. The dots change size. Um, this is kind of chaotic. And the reason this is chaotic is because what I've done, I've now assigned X and Y to geom point and geom smooth, as I had earlier, the example up here. But I've also applied color, the color geom to geom point, which we had done up here. But in the previous example, I didn't have anything in this area for color and size, right? It's just kind of empty. I didn't specify those aesthetics. And so by moving all the aesthetics to the top, size and color and Y and X, I'm applying these aesthetics to both geom point and geom smooth. And that's making kind of this wonky looking line. So what we do in this next one here, going back to the original plot, or sort of original, the previous plot, we can see that we've set our data source and we've set some aesthetics, the X and Y aesthetics, because we want these aesthetics to apply to geom point and we want them to apply to geom smooth. However, just in the dot plot, not looking at the line, we also want a color and size factor, but we don't want those color and size factors to apply to geom smooth, okay? We don't want that, and so we only leave them in the geom that they belong to, okay? And just as an example too, to talk about layering, I haven't given you an example of just geom smooth. If I comment out this line, you can see that my aesthetic for miles per gallon in X and weight for Y will apply to geom smooth. So if I run this, that's what the plot looks like. Okay. So if I have that plot and I have this plot, you can see how adding the plus sign kind of puts those layers on top of each other in order to get this plot, really. And you could argue that there are 3 layers here, because if you just run this first line, you get a layer, right? You get an X and Y. It's not a useful plot, but it's at least there. It's the axes, right? And then if you add, this one, you get a layer with the dots, right? And then if you add another layer, you get the layer and the dots and the line. I'm probably just beating this concept to death, so apologies if I'm boring. But that's the layering I want you to think through when you make ggplot graphs. So now I'll stop for a second. Any questions about moving the aesthetics? I really want to make sure that we understand how the aesthetics move. Does that all make sense? Oh, there's the chat. Okay, thank you, Elizabeth, for your kind words. I'm gonna take another sip of water. All right. So to recap, we've covered ggplot, making a very boring plot. We've specified what our data set is. And we've talked about how the aesthetics, when you assign them to the top, apply to all the layers of the graph. And if you assign aesthetics only within a certain geom, they only end up happening at that certain geom, okay? So to make just your brains hurt a little more, we're going to play with adding in some, wait, what did I do here? Okay, yeah, we're going to play with the aesthetics. So what I'm doing in this plot, I'll just run it so you can look at it. Sorry, skipped ahead a tiny bit. So now we're back to that original plot that was kind of wonky looking. But if you'll notice, the weird legend isn't here anymore, okay? And so what we can see is I've taken my aesthetics for the entire plot. I've made an X aesthetic, a Y aesthetic, and a color aesthetic. And the reason I'm getting 3 lines now instead of one is because this color aesthetic is kind of being carried down not only to geom point, but also to geom smooth, okay? Before we carried the color and the size down to geom smooth, that was this example here. And you can see how this carb thing was kind of weird and we got this warning and all that. So we've moved on a little bit from that. Um, so now we're at example 7. We can see how color got carried down into smooth. And one thing to know about ggplot, there's sometimes an aesthetic called group, and group tells you what does group tell you? Group tells you how to group things together, basically. So I could do group equals as factor cylinder. And that would also say like, hey, I know you're going to make this line, this geom smooth, and I want you to make 3 groups of like 3 lines each for one of the 3 groups. Okay. Uh, I might be making this more complex than necessary. Basically, color is getting carried down into geom smooth because we're assigning it at the top. And that's causing it to have 3 lines, okay? Because it sees that there's 3 levels of cylinder, so it decides to make 3 lines. Something else that's important to note about these geoms is that in addition to assigning the aesthetics, you can also assign non-aesthetic features to the geom. And this is kind of a weird word because I would argue that this still like qualifies as an aesthetic in the way that aesthetic means what it does in English. But basically, if I add standard error equals false and run this, you get the plot without those big confidence intervals. Okay. And the reason I know that I can type standard error equals false is just because I've typed it a couple of times before. If you were just starting and you wanted to make this plot and you're like, how do I get rid of the big gray confidence intervals? You could just type into Google geom smooth, get rid of confidence intervals, and it would tell you, oh, use standard error equals false. Okay. But I want to bring your attention to the fact that standard error equals false is not inside an aesthetic. Okay. It's not inside this aesthetic function. It's out of the aesthetic function entirely. Okay. Which isn't a big deal. It obviously modifies how the smooth geom shows up, but it's not in the aesthetics. Okay. Aesthetics are for variables in your data. I should have started with that earlier. That's the way to think of them. You're assigning variables to have certain qualities in the graph. And anything outside of those aesthetics are not kind of going to be represented. They just affect the thing itself without being related to any variable. Does that concept does that concept make sense? Any questions about assigning things, or not assigning things, but specifying things outside of the aesthetics? And the fact that aesthetics are paired with variables. Okay, cool. Aesthetics are variables. I should have started with that a long time ago. I'm sorry. Okay, so one other thing we can do, we can play around with, I am going to make this plot because let's say I want a line for the blue stuff, and I want a line for the green stuff, I want a line for the red stuff. But let's say I also want like an overall line of best fit. Okay. And what we can see here is that, I've assigned X and Y to all my groups. I've specified what variables I want to be shown in geom smooth. So I assign variables in the aesthetics. I'm doing size and color of the dots. That's great. Um, then when I make my 3 lines of best fit with geom smooth, I'm assigning group equals as factor cylinder. That's that group thing I was talking about. I'm assigning the group to say, hey, I want cylinder to be represented in 3 different ways because I'm making it its own group. The grouping language is kind of weird. I feel like I'm not explaining it well, but I'm sure you'll pick up on it if you mess around with it. And then, of course, within this geom smooth thing, we're also coloring the color of those lines based on cylinders. Okay, so the geom smooth, we're saying, hey, of this smooth thing, or we want you to make three of them to represent the three groups. And of those three groups, we want their colors to be represented. So the variable cylinder is represented by both the grouping and the color. Then you'll notice that outside of the aesthetic function, right? So here's this parentheses that corresponds to this parentheses. I've put a comma and then standard error, because this standard error equals false is not a variable. So it's not going to be inside the aesthetic thing. It's just referring to the geom smooth overall. Um, so that's that. We already covered that in section 7 there. And then, of course, I'm adding a layer, right? So I'm adding this layer for geom smooth. And you can see that I'm using two of the same geoms, right? I have a smooth thing on top of another smooth thing, which works out because the first smooth thing, I've specified that I want there to be 3 lines, or not necessarily 3, but I want there to be as many lines as there are groups of cylinders, right? Um, so here we have another geom smooth line, which allows me to get this big line that fits the whole data set and the 3 little lines that fit the smaller elements of the data set. Other things that are good to know about geom smooth, most people don't use smoothing lines. So you can write method equals linear model here and run that as well. But you'll notice, again, because I've specified method equals linear model, only in the second one, only in that layer for the overall line, the individual small lines are still curvy because that is controlled by this layer, and I have not specified that they're linear models, okay? And again, if you didn't know how to make a straight line, you didn't know inherently that method equals lm makes the straight line, you could go into Google and be like, hey, how do I make geom smooth straight line? And it would tell you method equals lm. The help on Google for ggplot 2 is astonishingly good, so enjoy. Any questions? Or I'll get through one more thing. Okay, so the last thing, we've made this ggplot. I'll run it first, right? We've made this plot. We've specified that we want the dots, and we want the dots to vary by carburetor type and cylinder type by color and size, okay? Then we've made a bunch of squiggly lines with the geom smooth function, and we've said that we want those lines to vary, 1, by type of cylinder, and 2, we want their color to also be by type of cylinder, and we don't want confidence intervals because it would be way too busy, okay? And then we're gonna add a big geom smooth line on top of that, another layer. Okay, and this is the part I always have to Google because I just forget it. Then you can add a bajillion different labels and nice little pretty things to your plot, okay? So you can do the labs command is just like another layer that you can do. Notice it's not a geom underscore sort of thing. It's just a label, a little more straightforward to add. So the title, I want to say car weight versus MPG. And the color, I want it to be number of cylinders. The size the size thing over here. I want it to be number of carburetors, okay? The X lab label, X-axis label, I want to be miles per gallon, and then the Y lab label, I want to be weight in terms of 1,000 pounds. And then this theme thing, this just makes it, if I run it without the theme thing, it's like gray. And if you run it with this theme, there's a whole bunch of themes you can pick from. It makes it less gray, a little clearer, I think, less busy. And so that's just to say you can add a lot of labels to stuff. And again, you can see I've written this labs thing 3 times, which is a little redundant. So if we were feeling certain of ourselves, it's always tricky to code uh, on the fly on Zoom. So we'll see if I can do this or not. Okay, so basically what I've done, I've taken all the labs and just combined them into one labs function. Let's see if it works. Okay, so same plot, going back 1 and forward 1. They look the exact same. That's great. Uh, that's just one way to make your code a little tidier if you want, but if you want everything lined up and down vertically too, that is also an option. Okay, so I think that's like, I think that was the final plot that we were working towards, if I remember correctly. But does anyone have questions about that? Questions about aesthetics or questions about modifying objects not in the aesthetics, questions about themes or labeling or any of that, feel free to ask away as I drink more water. All right, we got two. Oh, does R, okay. Do we need these little R things when we execute? If you are going to do this in R Markdown, yes, these are just functions of R Markdown, not necessarily a ggplot thing, but that's a great question. Let's say I open an entirely new R file, uh, and I copy and paste the code into it. I can just run this from here, and it will work. So that's great. The little thingies are just for R Markdown. Because if I was making a report, I could be like, the plot above looks nice. And it would show up in my report. This is just to specify to the computer, hey, this is R code. Great question. Okay, how many layers do you usually have on one plot? Depends on what you want on it. Exactly, right? That's exactly it. Sometimes one layer, sometimes two. You could make like a 5-layer plot. You could put like a dot plot on top of a line of best fit on top of another thing. But in terms of just the geomes, it would be weird if you had like 5. There'd just be a lot of information, right? So yeah, it depends on what you want, but probably not more than 2. I picked this example because it makes sense to have a line over a line of best fit. But if you made like a histogram and just a geom underscore histogram, it wouldn't really make sense to add a line of best fit over histogram. Maybe you could do like a density line. So then you have 2, but yeah, for the most part, it's not that many. How do I get the plot to show up in the plots window instead of showing up under the chunk? Okay, great question. I learned R without R Markdown first. So I like having it show up over here. If you go to settings and you do chunk output inline, let's see if this works. And I run it, then it will run underneath. And some people really like this workflow, but I can't stand it. So every time I start a new R Markdown file, I go to chunk output in console and then remove output. And then if I run it again, ta-da, then it's like, nice and large. So where'd the chat box go? Yeah, hopefully you can pick up some good R tips too instead of just ggplot. Okay, what is the gray area? What does it represent? And what is the code used? Okay, so this gray area is just like a confidence interval, basically. It's saying, we plotted this line, but because the data is big, the line could go anywhere through that gray area. It's just like a confidence interval. And the code for that gray line, so the gray line automatically shows up. But if I want to turn it off, I would do standard error equals false. And then the gray line would show up. So the gray line is there by default. You can turn it off. And if you turn off the turn off, I guess that's turning it on. But hopefully that answers that question. Yeah, cool. Great questions, everyone. It's much more fun to teach a course when people ask questions. Okay, I'll delete this. The plot above looks nice. All right, so now that we've figured that out, that is the bulk of this talk. So if you have to get going somewhere, no worries. You've gotten the big stuff. We'll go over some other quick little things in the remaining time. But that's most of it. You got the layers, you got the aesthetics, you got the things you assign to the layers outside of the aesthetics. You can figure out if you want your aesthetics at the top or inside the geom, that sort of stuff. Oh yeah. Also, do the attendance thing if you're gonna leave, because you might win a prize. Moving on, section 2, bar plots and reshaping data. Okay, this one might be tricky. Again, it's only for me to introduce it to you so you can Google it better on your own. I won't tell you everything about it. So let's say I'm just gonna run it real quick. Let's say I want a plot that shows the number of cylinders a car has and the average miles per gallon, like what I've produced here. Okay. So the 4-cylinder cars have an average of 26 or 7 miles per gallon, 26.7, I guess. The 6-cylinder cars have an average of 19.7 miles a gallon, and the 8-cylinder cars have an average of 15.1 miles per gallon. And I think someone asked this earlier in the chat, what do? Do you need to manipulate your data beforehand? The answer is yes. You do need to manipulate your data beforehand if you're making a figure in R. So in this example here, looking down, you can see the empty cars data set, which we already looked at. And this is some tidyverse. That might be, it's really easy for people who have worked with it and maybe complex for people that haven't. But what I'm going to do is I'm going to use the group by command. So I'm grouping this data set by cylinder. So like all the 6s are together, all the 8s are together, all the 4s are together. And then I'm summarizing it where the mean miles per gallon I'm going to represent by a variable called mean MPG. Okay. If you don't know what a pipe is yet, you should use it. A quick thing about a pipe, let's say I make this vector called numbers from 1 to 5. 1, 2, 3, 4, 5. Most R language, as I talked about already, the verb is outside the noun, right? So if I wanted to see the mean of numbers, I could do that just with this code. The pipe allows you to do this. Numbers mean. And it gives you the same thing. So instead of putting the function, the verb outside the noun, you can actually put the noun into the verb, like the cat jumped as opposed to jumped the cat. Okay. Um, Especially when you have like nested statements. So if I'm going to do print mean numbers, if you're reading that, you're like print the mean of the numbers. I guess normally that makes sense, but you could also write numbers mean print. So I'm going to take the numbers, then I'm going to find the mean, then I'm going to print it. You can also do that. So that's what this code means. I'm running low on time, so I can't explain everything. But basically what I've done, I've made this little data set where I say the number of cylinders and the mean miles per gallon. And that's the data set I'm going to work with. I've called that data set miles per gallon by cylinder. And then I'm going to plot that. Here, the geom that I'm using is call. Okay, so call is like a bar chart, but you use geom call when you refer to the actual values in the data. And you use geom bar when you want to talk about the count of something. So here, if I use geom bar instead, we can see that there are like 12 cars that have 4 cylinders, 6, maybe 9, whatever that is, that have 6 cylinders, and more cars that have 8. That's the difference between geom bar and geom call. Again, these geom bar and geom call like throw me off sometimes. So if you're like, this guy's rushing through this concept, I'm just telling you enough so that you can Google it. Okay. All that to say, sometimes you need to modify your data before you put it into ggplot, as opposed to putting it into ggplot and trying to modify it with different aesthetics or different weird things. I would just clean your data, make sure the data is exactly how you want it, then put it into ggplot. I'm going to make this pretty real quick. Ta-da! Just to go through this code briefly. So I'm picking this miles per gallon by cylinder, which is the data set I just made. I'm specifying that I want the Y to represent the mean miles per gallon and the X to represent the number of cylinders in the data set. Then I'm using the geom column. And the thing I want to be shown in geom column, I want the fill to be cylinder. So fill's a good thing to know. Fill is basically like color. But for some reason, so color like controls the dots, but fill, like you're filling the box with color. Okay. So that's why the aesthetic for geom call is called fill. If you Googled like, why won't geom call fill with the colors? When I use color, you're like, oh, I just need to use fill instead. That's the correct aesthetic to use. And then another thing to specify here. When I made this plot, you can see that the border of the lines is black. So when you use geom call, it's actually color refers to the outside rather than the fill. And you can notice that I've put this outside of the aesthetics because I don't want the outside color to be represented by a variable. I just want the same outside color to be there for every bar, for every column in the column plot. So if I put this on the inside for some reason, we'll see what happens. Um, okay, so it gets all weird, basically. That's not very helpful. If you do this and you're like, I can't figure out what's going on, it's because you specified something that you didn't want to be an aesthetic as an aesthetic. Okay. Then I label the the x-axis, I label the y-axis, and I for the key for the fill label, I just wrote equals number of cylinders. Oh, I should run it again so you can see it. Okay, so that's that. Other fun things, again, just to raise awareness, you don't have to memorize this. Okay, here I've made the same plot as above, but I'm going to demonstrate that if you don't like this salmon green and blue color, you can pick your own colors, which is really cool. And so one option, if you look up colors in R, you can see that R has a bajillion, not a bajillion, just 657, but a bajillion different colors that come loaded into R, and you can use all those. And so let's say you wanted, color 654, which is going to be like yellow too, right? Because this is 653, 654. This one's 657. Let's say that, and you picked your colors from this list. So I'm saying like of the colors, I want the 654th one. What you're gonna do is I've jumped ahead of myself. So scale fill manual allows you to manually pick what fill colors you want. Um, and what you do is you specify the values, and then for each of the bars, you say, okay, so I want this vector of colors, and in this vector, there's this color, right? And there's this color, and there's this color. I mean, they're boring because you're just like picking from the colors vector some location, but you can see that it's yellow too. Okay, so then ta-da, you could do that. Or if you didn't want to pick from the colors options in R, you could use like those hexadecimal color codes. You can specify those as well. So when I make this column and I do scale, fill, manual, where the values are equal to these three hexadecimal things, if you like work with colors a lot, they have a bajillion hexadecimal color codes online. You could run that, and that would get you three different colors, right? I just picked these, so that's why the colors don't match. But that's about colors in R. And if you're making a graph, if you go home after this a month later and you're like, how did Matt specify the colors? You can just Google like specify colors in ggplot for bar plot, and some helpful internet citizen will tell you to use scale fill manual, and they'll give you the code. So again, the support for ggplot on Stack Overflow is just beautiful. I'm skipping this because we're low on time, but basically it's the same concept as up here. Sometimes you have to modify your data. So if you have like long data versus wide data, you may have to change it from wide to long or vice versa. Um, so if you want to do like stocks over time, or this is like air quality over time, it's temperature over the day of the month. If your data is like this way, R is going to want you to put it this way. So it's if you like, yeah, I don't have time to discuss that. If you have questions, email me or something. Other fun things you can do. I'm going to talk about facets. Again, this is just for information. You don't have to learn this. I'm just opening your eyes to the coolness of R. If you have this plot that we made before, maybe displacement and MPG, and you want actually 4 different plots. You want it to vary by carburetor. You can add this facet thing actually, um, and it will make 4 plots or a lot of plots actually. I don't know how many carburetors there are. I guess 6, but that's a cool option. Um, okay, I got 10 minutes. The other thing, the last part of this that's really helpful is talking about how to save out your plots. And I should have left more time for this. There's a couple of ways to save plots, and there's some background knowledge you need first. There's 2 types of pictures that you can store on a computer, or there's probably lots, but there are 2 main ones. The first option is JPEG, and the second option is a PNG. JPEG stands for Joint Photographic Experts Group. This is what modern cameras use. If you have a phone and you take a picture, it probably saves that picture as a JPEG. And that picture gets reduced so that there's less data in that picture when you save it somewhere. There's also PNG, portable network graphics file. This can handle transparent backgrounds. Maybe that's interesting to one of you. It's not to me. And PNG take up more storage space than JPEGs. Okay. So most of the time, if I make a plot in R and I want to save it, I'm going to save it as a PNG file. And the reason for that is because if I save it, I want to be absolutely certain that it's not going to be really blurry when I zoom in. Okay. Additionally, if you have like a plot that you put on a poster for an abstract or a presentation or something, if you print the poster really big and your plot is really big, you don't want it to be blurry. Okay. So you want high quality, lots of information in your PNG files. There are a couple of options for exporting files. You really just got to mess around and figure out the best one for you. It will be a bit of a headache, but I'm certain you guys will be fine. So one thing, if I want, let me find a pretty plot to save. Maybe this one. Okay. If I want to save this plot in R, the first thing you can do is you can just go export, save as image. You can save it as a JPEG or a PNG or all these other things, right? And then you can specify the width and the height. So let's say I want this to be like 818. Update the preview. Okay, it changed. It's more skinny now. I can save it in some directory, and you can do that. That's one really easy option for you to save plots. Quick and dirty. It's simple. If you just needed to look at it on your own computer, definitely use this option. Okay, because it's easy. However, if you are exporting something that you need to look really, really nice, there are a couple options. You can use ggsave. You can use ggexport, which is in a different library, remember? So you'll have to download the package ggpubber publisher, I think. You can also use the PNG function. We have time for this. Sorry, let me look at my PowerPoint real quick. Okay, we have time for this. Okay, so basically, there's all these options to use. And I think right now my favorite one is ggexport. So I'll talk about that real quick. Okay, actually, we're going to make a plot here. This is called test plot. The reason it's so big and clear is because how we talked about theme earlier. I picked a theme where the element text, the size of that was 25. Bigger numbers equals bigger text, right? But let's say I'm presenting this on the poster. So I want the big readable text. And I just ran it here so you can see it. My favorite way to export plots is using ggexport. And the way ggexport works is you're going to write the name of the plot, okay? Because up here you can see how I wrote this ggplot thing, but then I assigned it to an object so that when I run this code, nothing happens. But when I run the name of the object, that's when the plot prints. So the plot that you're going to do, you do the file name. So you post like what folders it's going into, then .png, and here you put your name. So test plot ggport export 1. One thing to know about file paths in R, if I copy and paste a file path from my directory, say I copy and paste this one, you'll see that the slashes go one way. You want to make the slashes go the other way. Because if you don't, R won't be happy. So you gotta change all the slashes pretty much. That's just an important thing not to forget. So you put your file path for your file name, which is the path, and then the name of the file, .png. And then what you do is you pick a width and a height and a resolution. And images are tricky to talk about on computers because back in the olden days when you printed stuff on paper, you would pick the width of the printed paper and the height of the printed paper, and then you would print it, right? Um, but width and height really don't have, at least to me, an apparent meaning in the computer world because you can have really big screens, you can have your phone screen, which is really small. And so it's just kind of pick whatever you want, right? So I pick a width and a height. I normally it's in the thousands, I think. I think if really what matters is the ratio. Um, so pick some ratio of width to height that you think would match the graph well, right? So this graph that I currently have is kind of small. It's a little skinny. Maybe I make it wider. I think, oh, the wider graph actually looks good. I should make my ratio. I should make my width bigger than my height. Okay. Um, again, and you're just going to be messing with this, trying to figure out the width and the height. And then resolution, the Nature Journal, like the biggest journal of all time, requires a minimum of 300 DPI, dots per inch. Um, I think resolution is dots per inch. So I just put this at like 300 or higher. I don't know why I picked 340 for this example. Um, but there's that. So really quick, I'm just going to save this plot, load the package in. I'm going to save this plot, and I'm going to save this plot, and I'm going to go to my folder and open plots. Oh, there's too many. Let me do it again. So I'm using GG export to export these plots. And you can see the first one I make is nice. It's well, it's a nice looking plot, I guess. If you zoom way in. Wait, can you see my plot, or are you just looking at R? Can someone tell me what they're looking at right now?
We can see your plot.
Okay, perfect. All right, so if I zoom way in on this plot, disp, you can see it's getting a little blurry, but not that bad, right? If I blew this up on a poster, it wouldn't look too bad. So we can say that this plot was kind of successful. I'm glad I made my element text size bigger. That's great. Let's look at the other plot. Ooh, you can see it's a little smushed together, right? This isn't great. Um, and the reason that this one is more smushed together than the other one is just because in the second example, I used a width of 2,000 and a height of 1,000. And in the first one, I used a width of 5,000 and 4,000. And so really, whenever I save a plot, I just like mess around with these width and height things and leave the resolution as is. And I try like 8 different combinations. And eventually I'll come upon a combination that looks good enough. And when I zoom in, it doesn't look blurry. And that's what I'll go with. So I'm gonna look at the two chat. Yeah, plot, cool. There's other things you can do. You can use this PNG thing, but that's kind of weird because then you have to use this developer and turn it off. You can also use ggSave. This is the most basic one. I probably should have started with that. Where whatever plot you have up now, you just type ggSave and it comes up, test plot ggSave1. It takes a while to save though, and sometimes it's a little more blurry. So the one I just made here, this isn't that much more blurry. Actually, it might be clearer. No, let me zoom in. But anyway, that's a crash course on how to save plots. We have 2 minutes left, I think. So I won't say anything else. But hopefully that was a good tour of ggplot. I hope you understand the concepts and you are armed with enough knowledge to Google things when you run into problems. But thanks for listening. I hope to see you at the stats soiree. If you have questions for me, just look for the tallest person in the room. And yeah, enjoy your week. Enjoy the other presentations. Samantha, I think you need them to take attendance. Is that correct? They have.
Yeah, I already put the link in there, so in
Okay,
the chat for anybody that needs it.
cool. And with that, I
So
think I'm gonna turn off the recording and say goodbye to you all. Thanks for coming.
why don't we stay on until everybody